Okay. Well, the last time we do something about parabola. Parabola is easy to recognize because completely different to the ellipses. So ellipses recognize because the equation contains in between. However, parabola no. Parabola have x squared and y or and x no square. So one variable is degree 2, another is degree 1. Basically, we have 4 kinds of parabola. For example, the first one is x squared equals 4p y. And this is vertical. Chan chan. Like that or like that. Depending if you open up or down, depending the sign of p. Si p is positive, si p is negative. And we have another kind of parabola, que is like that. The horizontal parabola, open that or that, right or left. Depending the p values. Si p is positive, is to the right. Lauren Guerra, okay. Yes, what is yes, Lauren? You are ready, no? Okay. Okay. And negative is to the left. Okay. Another important thing. Well, this is the equation of the parabola under the supposition text is located at 0,0, no? So we have some translation que normally we call h and k. For example, this is x minus h squared is equal 4p y minus k, no? Likewise, the other is y minus k squared is equal 4p x minus h. Entonces, what is the important point in the parabola? Important line, something, no? Always, when you are doing the sketch of the parabola, don't forget to look. Suppose, hypothetical. This is the parabola. Suppose this parabola is the horizontal parabola. Okay. Entonces the equation look like that. Que p is positive. That is the reason que open to the right. And this is super important point, the vertex. The vertex. We have no center in the parabola. We have vertex. And the vertex is located at the point h, k. Que is the component for this. But we have more information. We need to specification. For example, the focus. The focus is a point that always is inside the parabola. And the focus is here. So never the focus is outside. No. Impossible. And that distance is p. That's it. Entonces we're using the same component, no? H, k, but in this case, because the horizontal parabola, you translate a little bit to the right, p unit, and you locate the focus. This is a focus, capital F. This is capital B, vertex. However, we have in the focus part, we have one important segment. Okay, this segment is called focal diameter. And this is important endpoint of the focal diameter. The total distance of the focal diameter specifically is 4b. Okay. Now, half is 2p to p. To find the component of this point and this point, well, from the vertex, you increasing in this case because it's horizontal, no? In the other case, no? You increasing the y component to p up and to p down. Finally, we have the famous directrix. Directrix is line. In this case, vertical line. Vertical line, directrix. And directrix have exactly the same distance P. Sorry, the scale is not good. P is in the opposite direction. Okay? And finally, we have the axis of symmetry, que es in this case horizontal line, que split the parabola into equal parts. That is the reason it's called symmetry. Axial symmetry. Que in this case horizontal is y equal, I suppose que es k, ¿no? Que es the component for the vertex, ¿no? K. And this is, okay. This is the information I need to provide in any problem of the parabola, no? Because I don't like que you memorize a stupid equation. Bueno, the only stupid equation que you need to not memorize, but we use it is this and this. This, and this. The only you plot directly on the plane and using your knowledge about the location of the vertex, focus, directrix, and point focal diameter, bam, you are doing like it, pero using just geometry. No formula si es h plus 2k, 2p, no. I don't. Well, you can. Some book and teacher recommend memorize. No, memorization, no, because suppose you memorization right now and you forgot in 1 week. So the important that you get in your mind is the concept. You need to understand the important thing inside the parabola graph and you plot that. Okay, let's move on to the example 3. In example 3 we have now translation. Example 3 is y plus 3 square equal minus 4 x minus 2. U identification perfect gets parabola because y is square and x is no square, it's linear. And U identification something is we are talking about horizontal parabola because y is square and x is no square. And identification also que 4p is equal to -4, que is this coefficient in front the parentheses, therefore p is -1. Therefore this parabola is horizontal but open to the left in that direction. Okay? And also you can see now that the vertex, that point, is located at the point. Look at h and k. At the point, 2, positive 2, comma, -3. This is the vertex. Okay. And p is -1. And the focus, one of focus, I suppose, is here. Okay. At what distance? 1 distance to the left. Therefore, the focus is located at the point 1, -3. That's the focus. Okay, it's exactly the same. It doesn't change the y component and decreasing. In this case, decreasing because it's to the left, the x component. The directrix, well, I suppose it's a line like that. And the same distance is 1. And see, this vertex, the component is 2. This line is a line x equal 3, no? Make sense? This is a rough sketch. No, after we go to the algebra and we are doing in detail. By the way, in the email I sent to you today, I sent also the link connected with my script of the conic section. You can use it anytime this. Okay, so if you want, no? So, you create your own. And finally, the axis of symmetry, well, is this line, que es horizontal, y equals something. y equal what? Y equal negative 2, que es de negative 2, ¿no? Negative 2, negative 2, yeah, negative 2. Negative 2, es negative 2. Yeah, it's negative 2. Okay. And the endpoint of the focal diameter, let's see in Desmos now, in detail. Okay, look, let's go. Now, Desmos, conic section. Okay, let me guide you to how we're using this script. We can manipulate, don't hesitate, see you screw up everything, no, it's okay. See you delete accidentally one equation, no problem. When you finish, when you close, don't save, and that's it. Okay, let me try to share the screen to the top part. Okay, there you go. Now we are talking about example 3 parabola. Okay, this. Look, example 3 of parabola, the graph look like that. Bam. However, in the paper, I discover que H es 2, K es negative 3, and P es negative 1. Entonces, now the script automatically, directly, you select the category of the parabola that we have, que es horizontal, no parabola. Bang! And this is the idea. The idea is, if you want to see, well, okay. I have here, so you open that arrow, you see the super general equation. Okay, I don't want you memorize this. No. Okay, and you see. Let me see. Remember the vertex was 2, negative 3. Nice. The focus was located in the point 1, negative 3. Nice. The axial symmetry is the horizontal line passing through to y equal negative 2, no? Negative 2. And the directrix is the vertical line, x equal 3. Look at this is 2, this is 4, this is 3. And one more information. Oh, the endpoint for the focal diameter. Okay. From this point is the focus. 2p in both directions. And 2p is 2. Because p is negative 1. Entonces the absolute value is 1. And 1 times 2 is 2p. Entonces you're increasing, for example, from the point focal, que es 1, negative 3, you move it up 2 units, to see increasing, of course, the y component. Minus 3 plus 2 is negative 1, and minus 3 minus 2 is negative 5. Okay, end the story. Any question? Piece of cake or piece of rock? Super easy. I suppose, eh? Okay, let's complicate a little bit now. Let's move on to the whiteboard. Okay, whiteboard now. Example 4. The example 4, you have to manipulate a little bit the given equation. Example 4. In example 4, we have 4x squared minus 20x minus ay plus 57 equal to 0. You identification, ¿es parábola o no? What do you think? ¿Parábola o no? No parábola, parábola. How do you recognize que es parábola? What is the clue que give me information que es parábola? Well, que x is a square. Well, I have a square here and no square here. But remember, no square means like a translation. Okay? It's some shift. In this case, is spherical shift. Okay. And y is no square. And this give me information que es parábola. What kind of parabola? Vertical parabola or horizontal parabola? Oh, es obvio que es vertical. Because I know que cuando x es square es vertical. I don't know si open up or open down. I suppose que open up. Bueno, pero I suppose, I am not sure. So let me try to manipulate this equation que is given in general form. More or less when the right hand side is 0. And you organize in descending order of the degree. Pero I need in standard. Standard is, ¿cuál es the standard? Standard of the parabola is standard form. And in this case, matching perfectly x minus h squared is equal to 4p y minus k. I need to manipulate this in order to express it in that way. Okay, to say always help me the completed square. So you take 4x squared minus 20x and you factorize it. You see that the great common factor between 4 and 20 is 4. And factor out. We have x squared minus 5x plus something. And something is the magic number that help me to complete the square. Okay, and the right, when I move the rest, and the rest is ay minus 57. And don't forget the box. Okay, the box is the number that you introduce here artificially in order to complete the square. However, when you introduce this, in order to doesn't affect the equation, you put in the right hand side, no? To keep the equilibrium of the equation. Remember the formula for the magic number is b divided by 2 squared. And b in our example 5. I don't care if it's negative or positive. It's not important. 5 divided by 2 squared. And this is the magic number here, but it's a number 25/4. Now, when you introduce 25/4, I guarantee you that this trinomial is perfect square, nice, and the factorization is super easy. However, in order to keep the equilibrium, I need to put it here in the box, not 25/4, sino 25. Remember that 25/4 is multiplied by the 4 outside the parenthesis and represent actually 25, not 25/4. Okay, let me try to finish. So now we have 4 and the trinomial is one binomial square because it's perfect square, and the perfect square factorization always is two identical twin brothers factors. Is x, is the square root this guy, and the square root this guy in 5 over 2. And the sign is minus here because it's minus here. Okay. And the right hand side, well, we have ay. We combine like term here is negative 32. And why no? Compute the greater common factor here gets 8. Entonces es y minus 4, ¿no? Finally, remember in the standard form, the coefficients here is 1. So the only coefficients we have is 4p, okay, is in the left. Therefore, I recommend you divide by 4. Divided by 4. Okay, so my equation so far is x minus 5 over 2 squared is equal to times y minus 4. Okay, this is my elegant equation. After the manipulation of the completed square, so I can see clear, for example, que the vertex of this parabola is located at the point 5 over 2, 4. Or in decimals you prefer to see more clear. It's 2.5, no? 5 over 2. And P, I don't know, P is this, remember in the standard is a 4P, look, 4P. For P is 2 in our specific example, therefore P is half. So the P is positive. So the conclusion is the parabola open up because P is positive, and this vertex is that point. So I need to determine the rest, get the focus, endpoint focal diameter, axial symmetry, and directrix. Okay? Of course, I want to use endesmos to make fast because we have no time. Today we need to start a new chapter. Now, let's go. Okay. Share screen. Screen desmos. Okay. I suppose in that moment you see desmos. I have the previous problem. Now I want to discussing the example 4. Example 4 look like that. Okay, 20. Okay, make it zoom. Oh, it's expecting. It's a parabola. A vertical parabola. Open up. However, here you set up the H and K. Well, H is 2.5. You put it directly here, not in the handles. Directly you type in 2.5. 2.5 is H, and K is 4. And P is 1/2. I recommend you type in decimal, 0.5, negative, no, it's negative 0.5. Okay, and the categorization for this is a vertical parabola, no? Boom. Pero open, because I made a mistake with the sign. It's no negative 1/2, it's positive 1/2. Okay, there you go. This is our parabola. The vertex confirmation 2.5, the equation for the directrix is y equal 3.5. This line is 3.5. Look. 3, and between 3 and 4 is 3.5. The axial symmetry is 2.5. It's expecting because passing through the vertex. And the endpoint for the focal diameter is 3.5, 4.5, and 1.5, 4.5, because basically you move to P, que 2P is 1, by the way, because P is 1/2 in both directions, right and left. Any question? Guys, do you understand very well? Entonces, remember, you checking by hand if you want. I understand. Jasmine said, I understand. Okay, entonces no more parabola for today. Let's do something. Y is over. Because P is positive. Banks. P is 1/2 positive. That is the reason que is open up. Clear? So the control in what direction open the parabola is given by P. Si P is positive, up. Okay, super. Okay. Let's move on to the hyperbola. It's the last conic section we study hyperbola. Now hyperbola. Okay, hyperbola look like weird, but no, it's not weird. Look at that. Hyperbola is a curve que contains 2 branches. Maybe like that, and maybe like that. The equation of the hyperbola expressed in standard form is, for example, x squared over a squared minus y squared over b squared equal 1. We have this possibility and we have that possibility. y squared over a squared minus x squared over b squared equal 1. Entonces the student always confusing because this is similar, but no, it's not exactly the same for the elixir. In the elixir, are you familiar que A is the major axis? In other words, A is the big number, but in the hyperbola, no, not necessarily it's the big number. Okay, A is always the coefficient in the positive part. Look. Still in Desmos, wow, sorry. Still in Desmos. Okay, repetition again at the beginning. Okay, hyperbola contain two branches. We have this kind of hyperbola. Okay, by the way, this is horizontal hyperbola. And this is vertical hyperbola. So the equation for the horizontal hyperbola is like that. So I try to explain one thing is confusing. At the beginning, when a student learn that part, confusing, because the habit that we have is the habit for the elixir. So in the elixir, we have again the same parameter ABC. We have C here. We study in a few minutes, in a few seconds. But in this case, different idea. In elixir, A is the major axis or semi-major axis. So the A is a big number, and B is the small number. But in this case, no big, no small. A is the coefficient que contain the positive part of the equation. Look, A always is the positive, but maybe the positive is X or the positive is Y. When the positive is X, and you immediately identification, this is A and B is a negative, and here is A is a positive, but associated with the Y. When the X part is a positive, we have horizontal. And you need to be familiar with the new terminology. We have one axis here. This axis is called transversal axis. Transversal axis. This is the most important axis. You know, the parabola is axial symmetry. No, we have no axial symmetry. It's transversal axis. We have another axis here, but this is not important. Forget about this axis. This is a conjugate, it's an A, but it's not important. The important is the transversal. So identification, wow, my equation is horizontal parabola because the transversal axis is parallel or coincident with the x-axis. However, in this case, the positive part corresponds with the y. Therefore, my transversal axis is parallel to the y or coincident with the y-axis, depending on the situation. So this is the equation when you have no translation, and when you have no translation, it's because you suppose that the center, in this case we have center, look here, this is the center, is located at 0,0. But when the center is not 0,0, it's another point. H, K normally is the letter that we use for the center. H, K. Well, our equation changed a little bit. It's x minus h. Remember, the h letter is associated with the x always, anytime. Minus y minus k squared over b squared equal 1. Here it's exactly the same. Y minus k squared over a squared minus x minus h squared over b squared. Okay, that's it. No, we have more information. We have more weird information. Look, when you are doing the graph of the hyperbola, mandatory, you need to draw asymptote. So the hyperbola contains asymptote. What kind? Is it like a slang asymptote? Like that. Bam, 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 bam. Bam, 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 bam. Bam, 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 bam. It's a slant asymptote passing through the center, of course. And the slope of this line, let me make a zoom, or let me try to do another more elegant sketch. Look. Okay, suppose here, this is my hyperbola. Suppose horizontal. Doesn't matter, this is the same. And both. Okay. However, we have here the asymptote passing through the center. In this case, to simplify the thing, I suppose que es 0,0, pero no necesariamente 0,0. Si the center is h, k, well, it's h, k, no? And some people prefer to do auxiliar rectangular like that when you are of the one hyperbola. Some people doing auxiliar rectangular here. Okay, this, by the way, is called reference rectangle. And the dimension specifically for that rectangle is this segment A and this segment FB. Therefore, it's obvious, look in the picture, que the slope of this line is raise and rho, no? It's B divided by A. So the equation for this both asymptote expressed in point slope form is, well, in this case, the center is the origin is y equal plus or minus b over ax. Okay, and the case que the center is located at the point h, k, well, is e minus k is equal plus or minus b over a paréntesis x minus h. Okay. That's it. No, we have more detail. Well, this situation working perfectly when we have the horizontal hyperbola, pero suppose que we have vertical hyperbola. See, we have vertical hyperbola. Now remember, vertical hyperbola is the hyperbola in which the positive term is the term que contain y. Entonces, my hyperbola is like that. Okay, I suppose again, to simplify the thing, it is also the famous asymptote. And we have, why not, the famous reference rectangle. Okay, this is auxiliary construction. Okay, help me to, well, to find this corner, this corner, this corner, this corner, and the center, and you connect it by the line, and this is the asymptote, right? Well, so the equation for the asymptote in this case is different. It's y equal plus or minus again, pero a over b, because this segment now is b, and this segment now is a. It's the only detail. And the equation when the center is located in another point different to the 0,0 is plus or minus a over b x minus h. End the story. This is the completed picture about hyperbola. Okay, let me summarize. In the hyperbola, the new detail is, well, you recognize the hyperbola because x is a square and y is a square, pero es minus. No, si es plus es elixir, you know. Pero si es minus es hyperbola. And parabola, remember, x is square, y no square, or y is square and x is not square. This is parabola. This is the super easy way to identification in 1 second what condition you are working. Entonces now we have the formulas. We have two kinds of parabola, vertical and hyperbola, vertical and horizontal, and depending the direction of the axis of transversal. And how do you know that? Well, you know because the positive part, CSX, entonces es because the axis of transversal is parallel or coincident with the x-axis. Likewise, or likewise, no, otherwise, is when the is y is positive, to say the axis of transversal is parallel to the y-axis. And finally, the detail is making the graph of the asymptote. And the asymptote, as any asymptote, the curve approaches but never touches. So see, we are doing well after we are doing super well in Desmos. So this is the asymptote, it's a line, and the curve approaches but never touches. Okay? In any direction. Entonces, you are ready to see example now? I bring 1, 2, 3, 4 example. Okay, example 1, easy. Always example 1 is kindergarten example. Example 1 is x squared over 4 minus y squared over 9 equal 1. Immediate identification, we are talking about hyperbola. And the positive part of the hyperbola is coincident with the x, therefore our hyperbola is like that, a horizontal hyperbola. Because the x is positive, I suppose that the axis of transversal is like that. Okay, immediate identification of A is 2, well, actually, A squared is 4, A is 2, and B squared is 9, therefore B is 3. So you see in this case, A and B, so in the elixir, always A is the bigger. In the hyperbola, no. In the hyperbola, A is associated with the number in the positive part. If you want to compute the position, I forgot to say focus, carajo. I forgot to talking about the focus. The focus of the hyperbola is located here inside, similar to the parabola, but we have two. So it's called foci, in plural, two foci. But it's easy because the distance, the focal distance is the distance from the center to the foci in both directions is called C. And the formula for the foci is completely different to the ellipse. This is the confusing part, and the student normally confusing the formula, confusing the concept. It's the same name, it's ABC, but it's different ABC, right? And C, que es the focal distance, is C is the big number, is A squared plus B squared. Therefore, C squared is 4 plus 9 is 13. Therefore, C alone is square root 13. Okay, in decimal approximation, because I want to plot that, is 3.606. Remember, decimals have 3 decimal places for the approximation. Now, well, let's do at least something. Okay, important. Let me try something by hand. I know que this is horizontal hyperbola. I know que the center is located at 0, 0. Why? Because I don't see any H in any case, no translation. I know que A is 2. I know que the axial symmetry no. The transversal axis is coincident with the x-axis. And on this axis lie the vertex. Vertex. What is the vertex? The vertex is this point, and this point. What distance? A. EA is 2. Therefore, one vertex is located 1, 2, 1, 2. And this is one vertex 2, 0. Another vertex is minus 2, 0. Okay. Now, what more information we need? We need the foci. Well, the foci is, let me use in green color. The foci is, the distant foci is 3.6. Entonces now es, bueno, I suppose que es 1, 2, 3, 4. 3, 4. 3.6 approximate here. This point is the point. 3,606,0, and here exactly it's a -3, -4, approximate here, minus 3.606,0 is another foci. Now, what I want to do this? No, not yet, because I want to make the reference rectangle. Well, one shortcut to do fast, because it's not complicated, is, you know, this is A and B. In this case, it's A and B, like that. A is 2, I did that. And B is 3. Entonces, 1, 2, 3. Here. 1, 2, 3. Okay, entonces one corner of the reference rectangle is like that. Another corner is like that. Another corner is 1, 2, 3. Another corner is like that. And you connect it now, the center and any corner. And this is my asymptote. Okay, by the equation of this asymptote. This is an important piece of information. Okay, now, entonces, approximately, roughly sketch of the hour. Hyperbola is passing through this point, open in that direction asymptotically, open in that direction asymptotically, vertex asymptotically, Remember, we have here focus, another focus, and also, why not, the equation for the asymptote is, well, let's say h and k is 0 passing through the origin, no? Entonces, it's like a y is equal plus or minus, because we have one slope positive, one slope negative, and b over a, b is 3, a is 2, 3/2. One equation for the both asymptote in this case. Any question, guys? Do you understand this or not? This is roughly sketch, no? But let's do it in Desmos to see more clear. Okay, let's go. Okay. Okay, ready. Okay, I suppose in this moment we are in Desmos, no? Okay, no parabola anymore. Yes. No parabola anymore. No. Infinite parabola. Okay, we are doing example 1 of the hyperbola. Get this. Bang. Wow. Okay. Because I just type in the equation. Okay. Now I determine in the paper que A is 2. No, actually, H and K, A is 2. B is 3. H and K are 0. No translation. P, I don't care, because P is the parameter of the parabola. Hyperbola only A and B. Automatically discrete compute C. The categorization is horizontal, no? Horizontal hyperbola, because the axis of transversal is horizontal, or at least parallel to the x-axis. Horizontal hyperbola. Boom. And you see now clear the center in green color, the vertex 2,0, negative 2,0, the foci located in this distance. Okay, remember this was square root 13,0 and negative square root 13,0, and determine the corner. Cannot necessarily do it in that way. You are doing the easy way. You suppose that A is 2, B is 3, A is 2, B is 3, and you connected that. And this is the equation of the one of the equation. The script don't give me equation, only do the graph. Any question of the hyperbola? Everything is clear in the hyperbola, or it's confused? Come on, guys, this is the moment to ask me any question. No question, just me. Okay. Okay. I understand. Let's move on to the more interesting example of the hyperbola, in which you need to modification a little bit the equation, because in this example 1, the equation gets given is standard. How do you know it's a standard? When the right hand side is 1, it's a standard, no? In the example 2, no. In the example 2, we have 16 y squared minus 9 x squared equal 144. This is the equation gets given, and the equation say do the graph of this conic section. I know identification. It's obvious it's hyperbola because it's minus, and x and y are squared. But the positive part is the y part. Therefore, we are in front of the vertical hyperbola. So our hyperbola look like that, round. Right? Because the positive part is the y part. This is expressed in standard. No, because in standard I know that the right hand side must be 1. So you divide whole thing by 145. And 145 divided by 16 is 9. And you put a 9 in the bottom like that. Minus, well, this is 16, no? By the same reason. Equal 1. Nice. This is my equation. I determine that A is 3 is obvious, right? Square root. This is A squared. And this is B squared. B squared is 16. Therefore, B alone is 4. And again, the center of this hyperbola is located at 0, 0 because we have no translation. We have no h, no k. Look, nothing, no quantity subtraction y and x. Centers. Okay, so this is the center. The vertex obviously is located on y-axis, because in this case they are perfect coincident between the y-axis and the axis of transversal. At what distance? Bueno, 3, que es B. Que es A, sorry. B es 4. Entonces this point is the point 0,3, and this point is the point 0,3. This is our vertex. In order to find the foci, well, I need to determine the C. And the C is super easy. C squared is equal A squared plus B squared. C squared is equal 16 plus 9, 25. Therefore, C is 5. Okay, nice. The foci is located out here. And the foci is located at the point 0,5 and 0,5. Okay. Now, finally, let me try to make it the asymptote. Okay, always passing through the center. In this case, the slope Well, in this case, slow. Let me make it zoom. Let me try to do bigger. Okay, this is our hyperbola, our center. The thing I try to find now is the asymptote. Okay. And remember the famous reference rectangle, but in this case the order is different. This is B now here and A here. I plot that point. In this direction I plot this point again, B, A. Okay, this is the same height, and here is the same. This is my reference rectangle, and the equation for the asymptote is y is equal plus or minus A over B. A is 3, B is 4, X. Mandatory. This is the graph approximately, roughly sketched by hand. However, this point is, remember, was 3, 0,3. This point was 0,3. This point is the force is 0,5, and this is 0,5. X-axis, Y-axis. Let's move on to this one to see more elegant and clear. Okay. 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 Now this was the example of the previous. Okay. Now let's do a number 2 hyperbola. What is this? Wow. You see this vertical hyperbola, so the axis, the transversal axis is located exactly on the y-axis. In this example, again, h and k is 0, a is 3, e and b is 4. And the category of this is vertical hyperbola. Vertical hyperbola. Bang! You see they are perfect coincidence. Look, look, look. Let me delete that. Go on. So it doesn't change. It's no coincidence. It's no coincidence. It's a mathematics. Okay? Again, center 0,0. Vertex 0,3, 0,3. Focus 0,5, 0,5. And the asymptote. This distance is 4. And this distance is 3. Any question, guys? No? Everything is clear? I know it's easy. No big deal. The problem is when they put miscellaneous problem. Yeah. The problem is, Sean, when you integrate everything, entonces maybe some concepts confuse ellipse, parabola, hyperbola. Entonces I don't remember very well. Well, it's okay, but you copy in one piece of paper the formulas, no? And classification, right? Okay, let me see a sample trick. It's more interesting. Because translation, suppose x minus 2 squared over 9 minus y minus 3 squared over nothing. And nothing is because this is missing, no? Okay, suppose I leave it like that. So you need to understand the formula is 1, no? Equal. This is the equation que es given. And you try to find the rest. It's obvious that we are in front of the hyperbola. The glucose hyperbola is minus x squared y squared minus in between. And the axis transversal side, the positive part is x associated with x. Entonces, our hyperbola look like that. Bam, bam, horizontal hyperbola. However, the center, the center is located no es 0, 0, is located at the point h, k. In our example, is 2,3. The center is located at the point 2,3. Now, identification of the A is 3 because it's a square root 9, and B is 1. It's a square root 1. Now, C squared is equal A squared plus B squared. It's 10 because it's 9 plus 1 is 10. Therefore, C is square root 10. It's approximately, put in the calculator, 3 point something, 3.162. And this is the focal distance. The axis of transversal is parallel to the x-axis. Okay. One more information. Well, we need vertex. The vertex is this point and this point. And this distance is A. Our example is 3. At this point would be 5, negative 5,3. This point is 5, 3, so you're increasing, and 5, no, negative 1, because it's negative 3 and the other direction is negative 1, 3. Okay, this is A, right and left. Okay. And the foci, well, the foci is here. See distance, que es 3 point something. So from the center, you adding 3.162, que es 5 point, approximately, no, 5.162, 3, and the other direction is negative 1.162, 3. Good. And the asymptote, well, it's easy. The asymptote is easy. Remember, in this case, the asymptote passing through the center. Okay, by the way, the center is no 0, 0, 2, 3. And the slope in that case is A here, B here. Okay, A and B. B is 1. And A is 3. So I suppose que the equation for the asymptote are y minus k, and k is 3, is equal, plus or minus always, b over a, que es 1/3, paréntesis, x minus k, h, sorry, h is 2. This is the equation, and normally, I don't know why, the style to represent the answer in the books is in this point slope. You remember the formula y minus y1 is equal m x minus x1. Some book put the 1, another book prefer y0 equal m x minus x0. So the thing I try to explain is, okay, I don't know why, but this is a one way to represent that. Is in this case point slope formula. No like a y equal mx plus b. You can, of course you can. So you distribute the property, isolate the y, you can, of course. But no, leave it like that. It's much better, more elegant. Let's go to Desmo to see the idea for this. Okay, entonces, in our example, let me see. Let me go to Desmos. Share screen. Okay. 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 No example 2, example 3. Let me see the equation. Look, in the equation I make a mistake, but I fix the mistake. F minor here. F minor. See, because I see in my paper I change something. Okay, boom. And this is affecting, look. This is the horizontal. Okay. I come back to the general idea. That's it. Okay, you know what the script is doing. Forget the student practice. So you type in any program. And you see in purple color our hyperbola. Identification. Wow, I am clear. This is the horizontal hyperbola. Okay. However, I need to verification. I need to verification. Entonces, en A I put 3, en B I put 1. I think I computed by hand in my paper. And H and K are, look, H is 2 and K is 3. I don't care P because P es el parámetro que corresponde with the parabola. ¿No? Entonces, the classification, we are in front of the horizontal hyperbola. Boom. Boom. And they are perfect coincidence. Look at that. And between, at least the curve is the same. It's no coincidence. Look, let me remove the region. You see it stay? Different color, of course, but stay. Okay, let me summarize quickly. Center, 2,3. Vertex, almost close to the focus. Look, 5,3, negative 1,3. Remember, C is close to 8 because B is small. B is 1, B is 1. And this is the corner of the reference rectangle with passing through the asymptote. And you see it's asymptote. Look at that. Let me make a zoom. Wow, approach it, but never touch. Okay, asymptote. Any question? Let's do in the last example of the hyperbola. Now, erase the board. Example 4. It's the last one. Well, in the review packet, maybe we spend more time doing example. Okay, and this is a little bit complicated because it's 11x squared minus 2y squared plus 66x minus 4y plus 75 equal to 0. Okay, to confuse you, to make a hard time for us, it's giving in general form. So right hand side 0. So I need to complete the square. In order to express it, the equation for the hyperbola in standard form. Okay? So I propose you grouping the x part as this and this. I can see that the great common factor is 11. I factor out 11. X squared plus 6x plus 1 box que contain the magic number que help me to complete the square. And the y part is here, and you factor out minus 2, y squared, y plus another, because I need to complete the square on both sides, equal, just in the right hand side, we have 75, because I moved to the right hand side like a minus 75, and you have 2 boxes. Okay, not necessarily it's exactly the same number in the left hand side, because remember, don't forget in the left hand side we have factor 11 and factor 2. So the number inside the first box is 6 divided by 2, okay, 3 squared is 9. This is 9 here. Cool. But actually, if you put 9 inside the balance, this 9 multiplied by 11 is 99. Likewise, the magic number in the second box is 2 over 2. I don't care the negative signs, not important. You take this actual value as 1, square 1. The number is 1. The number here is 2 times negative 1 times negative 2 is negative 2. Bang! Yeah, I complete the square like that. Okay, now I finish. No, cool, no. But I guarantee you that this trinomial is perfect square and the factorization is x plus 3 square minus 2 times y minus 1 square equal 22. Okay, the computation that part. 77, no? 77 negative 22. It's obvious que negative 22. Finally, okay, I remember the right hand side must be 1. You divide the whole thing by 22. Entonces, our equation, nice, expressed in standard form is x plus 3 square over 2 minus y minus 1 square equal 11, no? Equal 1. Wow, highlight that. This is standard. This is the same equivalence. You are doing the graph of this and the graph of this in decimals. It's the same. It's a perfect coincidence. It's the same. Different color, but it's the same curve. Okay. Quickly, because the number is weird. The center is located at the point minus 3, 1. It's the center. Remember, it's the opposite side. A is this guy, is radical 2. It's weird. And decimal is 1.414. And B is radical 11. And decimal is 3.316. And C square is A square plus B square. Okay, is 2 plus 11 is 13. Wow, everything is weird in this example. Now C alone is a square root 13, is approximately 3.605. Okay. Bueno, my recommendation is do the script to plot the point. And you compare with the common sense, right? And by the way, the equation for the asymptote in this case is, well, I forgot something. No, this hyperbola is horizontal or is vertical? It's horizontal, right? Because the positive part is associated with x. Entonces the formula is y minus k is equal plus or minus b over a parenthesis x minus h. In our specific example, is y minus 1 is equal plus or minus b is, wow, radical 11, a is radical 2. You put together, you want put together. Parenthesis x minus h, que es 1, is 3, es minus 3, sorry, es plus 3. Okay? Okay, let me try. Okay. I make a mistake. Look. When I factor out here, but I fix it now. When I factor out here negative 2, this is positive. But this is also positive, right? Because look, negative times positive is negative. And this only change que this is plus. And this is plus. Entonces de center es lo que es en negative 3, negative 1. I realize here in my paper now. Okay? This is the center, because the center is located at the point minus 3, negative 1. This is the transverse axis. Okay, it should be y equal -3. Okay, and this is the equation for the. Okay, wait a second, right? This change. This is plus, and this is also plus. Yes or no? Okay, let's see quickly. And then sweet. Okay. 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 Let me restore everything. It's the last example, example 4. Okay. Here, no anymore. Example 4 is I copy in the original way. Okay, let me check it. 11x squared minus 2y squared plus 66x minus 4y plus 75 equals 0. Okay. Now I discover que A es radical 2. Okay, I fixed that. I using the keyboard for decimals, I put radical 2. Radical 2. Bang. And B is radical 11. And H is negative 3. And K is negative 1. Okay. Let me do the graph of the original. Bang. Bang. This is the graph of the original. Let me try to do the graph of the theoretical now. Okay, I manipulate algebraically. Yeah, I categorize like a vertical, no, horizontal. Horizontal. Bang. Double bang. Okay, good. Center, negative 3, negative 1. This is the vertex, as we a number because it's irrational number. This is the focus here, focus. And this is the reference rectangle, and this is my asymptote. Any question, guys? Everyone follow me? This part is boring or is interesting? What do you think? Funny section. Yes, and Jasmine, look at that. It's very important when you take calculus, the teacher of the calculus, always we using conic section, okay? Always, anytime, using conic sections. So you need to be familiar with the conic section. You need to take calculus. Who need to take calculus? How many calculus you need to take? What is your major? One by one. Let me, for example, Lusting, major, biology. Entonces you need to take, Jasmine, only calculus 2. Lusting, computer science, calculus 2. Only engineer, a mathematician, and physics need to take calculus 3. Mechanical engineer, Queen, calculus 3. I am teaching now in the summer. Of course, you cannot take. You take calculus 1 first, calculus 2. Calculus 1 is a little bit hard. Calculus 2 is super hard. And calculus 3 is super hard. And you know, involve a lot of concepts. But you need to open your mind. You are going, yeah. Well, no, I don't know. Maybe yes, because I teach in calculus 2 in the last summer. So in this summer, in the current years, I teach Calculus 3. Maybe in the, so you need to take Calculus 1 in the fall, and so you need to take in the spring Calculus 2. I don't know. Sometimes yes, depending the necessity of the department. Okay. Anytime you don't lose the contact with me. I have a lot of students like you que take with me pre-calculus or this subject is equivalent pre-calculus, no? And contacted with me, for example, they are taking class in FIU and contact with me by email some question, no? Entonces we communicate by Skype or by email, depende, I solve it, I send the solution. Don't lose my contact, no? Always. Anytime que you need something about mathematics, please let me know. Well, entonces let's move on to another topic. Another topic. Do you see the whiteboard or no? I share. Let me see. Yes, okay. Okay, this topic is easy. It's about sequences. Sequences, and we continue sequences next time. So today is only introduction for the sequence. Okay, sequences is, it's like a list of numbers, no? It's a list of numbers. Pero no crazy, sino well done, o sea, que satisfy one specific mathematical law, no? Basically, you can interpret it like a function, but the domain of the sequence is the natural number. So the domain of the sequence is a natural number. A natural number is natural, is starting 1, 2, 3, 4, 5. Okay, and the A sub m, the name of this guy A sub m is the formula que connecting the sequence, and this is explicit formula. It's a technical name, however you call A sub m, and everyone understands very well what is A sub m. Entonces normally in sequence, for example, this is just example, n minus 1 divided by m. Let's say I ask you, for example, listing the first element of this sequence. Okay, yo evalué n equal 1. Entonces 0, a is 1, que is the first guy in the list, is 0, comma, a is 2 is 1/2 because it's n is 2, 2 minus 1 is 1, 1/2. A is 3 is 2/3, right? 2/3. I suppose m equal 3, 3 minus 1 is 2, and so on. A is 4 is equal 4, 3/4. And A is 5 is 4/5. It's a sequence. It's a sequence. So sequence is interesting because it's alternating. Alternating means que one element is positive and another is negative. So alternating, positive, negative, positive, negative, positive. Entonces now, for example, the classical way que you see, suppose this example, suppose A sub n. Remember, A sub n represents the formula, the explicit formula for the sequence. Suppose que es negative 1, n plus 1, times 2/n. Entonces we try again to understand the first 5 elements of this sequence, and you evaluate n equal 1, 2, 3, 4, 5. Remember, n is a natural number, and they want que you evaluate in 1, and 2, and 3, and 4, and 5. Let's see what happens. And stolen 5. Entonces es, the first guy is n equal 1. Entonces plugging in 1 here. 1 plus 1 is 2. And negative 1 squared is positive 1. It's invisible. Entonces 2 over 1. 2 over 1. O sea, it's just 2. Comma. This is A1. A2, well, you plug in 2. 2 plus 1 is 3. And negative 1 to the third power is negative 1. That is the reason that's alternating. Entonces 2, n es 2, 2 divided by 2 es 1, negative 1. Comma. A sub 3 is 3 plus 1 is 4. Negative 1 to the 4th power is even exponent, is positive. And 2 over 2/3 is 2/3, right? It's n 2/3. 2/3 positive. And you see, the first guy was positive, the second guy was negative, the third guy was positive. It's alternating sequence. Okay? And when you see in one sequence, one term like that, negative 1 to the n plus 1, or negative 1 to the n, not necessarily plus 1, this is alternating. And depending si es plus 1, the even are negative. Si es no plus 1, the even are positive. It's logical, right? Let's continue. A4 is 4 plus 1 is 5, negative again. It's 2 over 4, 2 over 4 1/2. And to the 5th power is positive. I'm expecting it's positive, no? Because it's 5 plus 1 is 6. Negative 1 raised to the any even number is positive, and 2/5. Okay? So this is look like elementary, look like just plugging in and that's it. Okay. However, sometimes happen. Okay, unbelievable. You have no in your hand the formula, the explicit formula to represent the sequence. No, you have the recursive formula. Recursive formula. It's important that you remember this name because in one moment of the calculus 2, you can see that the teacher explained this idea, recursive formula. What is the idea? You have no formula, no explicit formula. You have no. Unfortunately, A sub n question mark. You have no idea. You have the other formula que state the relationship. Suppose example. This is the classical example. One famous sequence in the mathematics gets called Fibonacci. Fibonacci sequence. Okay, this is a sequence discovered for the famous mathematician Fibonacci. It's Italian. Okay. And the Fibonacci sequence is starting 1. The second guy is 1. And the third one is the sum of this, que es 2. So 1 plus 1 is 2. And the next one is the sum of the two previous. It's 3, 5, 8, 13, and so bam, 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 bam. But it's impossible to find the explicit formula. Well, no. It's possible, but it's too hard. So it's ridiculously hard, complicated, very complicated. However, we can express it like a recursive formula, que is easy or relatively easy, because I know that the formula is A sub n plus 2 is equal A sub n plus 1 plus A sub n. Okay, entonces in any position, we have 3 elements. This is, I suppose that this is n. This is n plus 1, que is the next consecutive, no? And this is x plus 2. The number in the position x plus 2 is equal, according to the recursive formula, to the sum of two previous, this plus this. And you can express in one nice or relatively nice way the formula for the sequence. without to find the complicated explicit form. So sometimes we have this or this. Okay? So we expect the rest of the time. Guy, you follow me? It's easy, eh? This is easy. This chapter is when the mathematicians are talking about the teacher. What is the easy chapter in mathematics? Sequence. Sequence is easy. Okay, very important notation that we are studying now. Summation notation. Use summation notation. Summation notation. Summation notation. Okay, suppose that we have several elements in the sequence and you adding A1 plus A2 plus A3 plus A20. When you put this it's get repeated with the same part. So you can condense this information using summation notation. And summation notation using that symbol. That symbol is a Greek letter. Okay, sigma, capital sigma. When you put capital sigma, you put the name of the element is A. You declare one auxiliary index variable. I don't know, the people believe to call Ki. It's the most popular. K, I, J. I don't know why. This is history. Suppose K. You put it K go from 1, because it's the first guy. K go 1. To the last one gets 20. I don't know why. Don't put it at the top like that. K equal 20. It's weird to see that. You put just 20 in the top and that's it. And you expand or condense it depending the intention from 1 to 20. Okay? For example, the first example, you expanding this summation notation. Sigma from K1 to 5. And the expression inside 1 over K, reciprocal. Well, we start at 1 over 1, plus 1 over 2, plus 1 over 3, plus 1 over 4, plus 1 over 5. And that's it. Now 1 over 1, you know is 1. 1/2, plus 1/3, plus 1 over 4, plus 1 over 5. And if you want, you condense it again, you add it. But no. This is the idea was expanding summation notation. Let's do it now in opposite direction. In opposite direction is we have a summation in the regular way, 1 square plus 2 square plus 3 square plus, so I suppose continue. I suppose that the next guy is 4 square, 5 square, until 9 square, que is the last part, ending. How you express it in this in summation notation? You put the famous sigma word letter. You declare one index variable. Okay, I suppose it's I don't know, it's up to you. I, J, K, M is another popular. From 1 is the first, look here, to 9 is the last one. And the mathematical expression inside is I squared. Because you plug in 1 squared, 1, 2 squared, and so on. And this is the idea for the summation. Ahora, the summation is super important. In Calculus 1, you have to work with the summation notation. I want to study in detail now the properties of summation notation. Okay. we study in detail this. The first property is when you have summation from k equal 1, I declare always k, to m, is there n. And inside we have a constant. C is a number, just number 22. A sub k, this is no constant, it's a variable because depending the k, no? You can put the constant outside. This is logical. This is logical because it's a multiplication. The multiplication, you know, is the operation of the summation of the same number, no? So A sub k. So you can apply that property in which you the constant that doesn't change with the k, you put outside the summation to simplify the thing. The second property is summation from k equal 1 to m, and inside the summation we have two guys, a sub k plus or minus b sub k. Okay, this is the argument inside this k. I consider it like an operator. It's an operator, right? You can separate in two. A sub k plus or minus. So depending, it's addition or subtraction, doesn't matter. This is making sense, right? Sometimes we need to separate. Let's see in the example. Another important, suppose we have summation from k1 to m of a sub k. We can split, we can separate. We can separate into summation if you want. Sometimes we need to do that. A sub k, So for example, the first start in 1 from k equal 1, exactly the same with this limited, and ending in m. Yeah, suppose that m is smaller than m. So suppose that we adding from 1 to 40. Yeah, I split, no say from 1 to 20, m is 20 maybe, for k equal m plus 1, get 21 to the 40. Sometimes we need to do this. Okay, it's a logic, it's a common sense, right? However, this is important. We have 3 more properties to complete the pictures of the property for the summation. Number 4 is summation from k equal 1 to m of the k. Well, this is the summation of the first natural number. It's 1 plus 2 plus 3 plus plus the last one is m. And the formula is m multiplication by m plus 1 divided by 2. Wow, amazing. Okay, I remember one story. The one boy in elementary school, the teacher to waste the time say, student, now you need to add in the first 100 numbers. And the most of the students doing that way. 1 plus 2 plus 3 plus 5 or plus 4 plus 5. I skip 4, sorry. This is the natural order, no? However, the super brilliant student change the order of the summation. Suppose 1 and 100. Remember, I need to add it to 100. No? 1 plus 100 is 101. And 2 plus 99 is 101 again. No? And 3 plus 98 is 101 again. So always is 101. And how many numbers we have in total? We have 100 numbers, no? But we can form 50 couple, 50 pairs. So basically it's 101 multiplication by 50 is 5050. And this is the idea for this equation. Look, this equation, suppose that I need the summation from K1 to 100 of the first 100 number. So you compute it. This is 100, the formula. This is 101, because of 100 plus 1 divided by 2. And 101 is this number, and 100 divided by 2 is 50. A smart boy, eh? Okay. However, we have two more important expressions that you need to know in Calculus 1. Suppose that summation of the first, again, per square. Okay, this is like a 1 square plus 2 square plus 3 square and so on, until we finish. It's no infinity to n square. And we have formula for this. The formula is not obvious, but we can prove. But not today, of course. It's n plus 1, 2n plus 1 divided by 6. It's a one fantastic property. Okay, I guarantee 100% you use it in Calculus 1. Okay, and number 6 is exactly the same, but a cubic. Cubic, okay, cubic. 1 cubic plus 2 cubic plus 3 cubic, and so. So 1 plus 8 plus 27 plus 64 plus n cubic. The formula is, look, this is unbelievable. The formula looks like similar to this. I don't know why. However, this is a square. This is n plus 1 over 2, everything raised to the second power. Guys, I guarantee you that we can prove these formulas, but not today, using one method que is called mathematical induction. This is the topic, one induction. This is one topic we're discussing, the first topic we're discussing next class. Okay, let's do it quickly, but super quickly. 3 examples I bring for you. Any question, guys? Are you bored? Are you sleeping? Everything okay? Let me see. Wow, you follow. Yamin always follow me. Advance, are you okay? Lauren, Sean, Queen, Karen, Rhino, you good? Okay. Guys, I don't know if you feel or no, but this class is a little bit hard and intensive. I explained at the beginning, Lauren? I explained at the beginning. Okay, suppose let's do in 3 examples, 1, 2, 3, and that's it. 1, 2, 3. 1, 2, 3, using summation notation and the property we studied before. Suppose compute that. Summation from K1 to 5 of 3K. Bam. Bueno, we can expand. We can expand one by one, and compute it, but this is stupid, right? Suppose que I put it here 500. Entonces it's too long process. No. You apply the property. The property allow me, for example, in the first, these 3 you put outside. Because it's a common factor. And this basically is the sum of the first 5 natural number, no? Que es 1 plus 2 plus 3 plus 4 plus 5. Que es 9, 12, 15, no? Pero no. I don't want to do in this way. No. You're using the formula. What is the formula? The formula is n plus 1 over 2. The formula that we studied before. Entonces es 3 times n is 5 5 multiplication by 6 over 2. Entonces this is 30 divided by 2 is 15. Exactly this answer. Time 3 que we factor out outside 45. Do you see that? Okay. Let's do the second. The second summation from k equal 1 to 20. Yeah, to do by hand 1 by 1 is crazy. 5k plus 3. Okay, I propose you separate in 2 pieces. So one first summation is 5k, and 5 is a constant I put outside. And the second is k1 to 20 of just 3. And you say, well, professor, this 3 is a constant, you put outside. Yeah, you can put outside. Why not? You can. Of course you can. However, if you put outside, what number stay here inside the summation? Huh? See you there to put outside this 3, what number stay inside the summation? 1. Entonces now, suppose one way to analyze is you put the 3 outside, you have 1 here, and you added 21. 1 plus 1 plus is 20, no? That's 20. So what is the shortcut we are using? No, I don't like this way. You multiply 3 times 20 is 60. The answer of this is 60. And the answer of this, well, this is more complicated because this is similar to this. It's a 5, and remember the formula, and this formula we use again is 20 times 21 divided by 2. 20 divided by 2 is 10, 210 times 5 is 1050 plus 60, don't forget the 60, is 1110 is the answer. Good? One more or no? What? No more. Okay, I obey to Yasmin. Yasmin said, Professor, no more. It's too much. And tired, too long class, lecture. Well, no. Yasmin said, wow, no one more. Okay. I respect Yasmin. No one more. Okay, guys. So now, I love you so much. I need to prepare for the next class. Okay. Let me stop recording.